Alright, let's try again. Let's do some algebra. So I have r multiplied by s plus t. Oh no, let me do s minus t. Actually, so I have s minus t, and I ask you to multiply this, and you say, oh, okay, that's not a problem. I can use the distributive property, I can multiply this one times this one, and I have rs, and then this one times this one, and I have minus rt. It's like, oh, cool, yeah, no big deal. So now I tell you, okay, now I want cosine of s minus t. And you try to do the same thing. Okay, I know it's cosine of s minus cosine of t. And that's wrong. You cannot do that. This is a function. You cannot do that with functions. You can do it with variables, but not with functions. So actually, there's an identity. It's called the addition formulas for sine. It was one of four addition formulas for sine and cosine. And it says that if you want to have cosine of s minus t, this is actually equal to cosine of s cosine of t plus sine of s sine of t. And you say, well, that's pretty weird. Can you prove that? So we're going to try to prove this identity. So let's go to the next page, and I have a couple circles, and let's analyze them. So I have a triangle. First of all, I have a unit circle. So that means the radius is 1. So this is 1. This is 1. So I have a triangle. And what I do from the second circle, I have the same triangle. I just rotate the triangle clockwise. So this side is now this side, flush with the x-axis. But it's still the same triangle. Notice here that s minus t, that's the this angle. So we have s minus t here. And let's see if you agree on the points. So I have point P here. In the unit circle, x is actually cosine of the angle. So I got xy as cosine of t, sine of t. Same thing here. I have the angle s. Angle s, just analyzing this line. So angle s, analyzing so we can get the coordinates for this point right there. So again, we have the reference angle here. For the reference angle for angle s is this one right here. So I can do the same thing, cosine of s, sine of s. And yeah, remember, cosine is actually x in the unit circle. Sine is y in the unit circle. So cosine, sine. Okay, so you agree that these triangles are exactly the same size and same, they're congruent. They're actually congruent or identical triangles. Okay. Now, this point, well, we know the coordinates because this is the unit circle. So x is 1, so p equals 1, and obviously y equals 0. Now this point. Now, we're going to work on instead of working on the reference triangle and all that stuff, since the initial side and the terminal side, the initial side is at 0, so we just use the whole angle, s minus t. Just copy from here, same angle, s minus t. Okay, so we have the angle. So the x coordinate for this angle is actually the cosine of s minus t, and the sine is the sine. I mean the y, the x, y, the y is a sine of s minus t. Yeah, just copy s minus t, same angle, and we just update the notation here. Okay, let's make sure you understand what's going on. Now we're gonna start the proof. So we're gonna use the distance formula to create the proof. So the distance formula is this. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. All right, so we're gonna use that. And like I said, on the unit circle, x is a cosine and y is a sine. So this is x2 and x1, y2 and y1. So let me start. So PQ is actually equal to the square root of x2 minus x1 plus a square plus y2 minus y1, which is square. Okay. Now we're going to use the binomial square shortcut that says that the is cosine square of s minus 2 cosine of s cosine of t plus cosine square of t. And I don't have enough room, so on the bottom I'm going to do this one. Same principle, sine square of s minus 2 sine of s sine of t plus a sine square of t. So that's the so PQ is equal to the square root of all that garbage. All right. So now notice that we have a cosine square of s plus sine square of s. Remember that identity? Sine square of s plus cosine square of s is equal to 1. And we have another one here, cosine square of t, sine square of t. So whenever you have the cosine and the sine squared, adding together, you get a 1. So now we have a 2. And then just copy these two guys. Minus 2 cosine of s, cosine of t, minus 2 sine of s, sine of t. So PQ equal the square root of that. Okay, so we're done with the first circle. Now let's start on the second circle. Same thing, we're going to apply the distance formulas. So PQ equals, now let's scroll down a little. So we're going to do square root of x1 minus x2. So that's square. So cosine of s minus t square plus oh no back up. So that's x1 cosine of s minus t minus 1. So that's x2 minus x1 because x1 is 1. Okay, square plus same thing on the other side, y2 minus y1 square. So y1 is actually 0, so we just have y2 square plus sine square of s minus t. So we're gonna expand this one, this binomial. So you got cosine square of s minus t minus 2 cosine of s minus t plus 1. And then this one plus sine square s minus t. Alright, so we have that. And let's see if we can do some crazy stuff here. Again, we have a cosine square and a sine square. So we get these two, and so we get a 1 there. And then this other one, so we get a 2. We get a 2. And then we copy this stuff, minus 2 cosine of s minus t. And that's PQ equal square root of that. Let me scroll up a little. So we were doing the same triangle, and by translating triangle, we got two different equations here, but they're actually equal because they got PQ here and PQ here. So this equation or this expression is equal to this expression. So I'm gonna turn to blue, and I'm gonna make another I'm gonna make another equation. So now I have, first of all, both of these have a radical. So if I square both sides, then the radical is gonna go away. So I have 2 minus 2 cosine of s cosine of t minus 2 sine of s sine of t equals 2 minus 2 cosine of s minus t. Now what I can do something drastic and say, hey, I can get rid of this one and I can get rid of this one. Just subtract 2 from each side, and we have that. And what else can I do? Well, over here I can factor out the 2. So I can put a minus 2 here, and I have a cosine of s and cosine of t plus 2 sine of s sine of t equals minus 2 cosine of s minus t. Now I can divide both sides by negative 2, and so I can cancel these ones. And guess what? I got cosine of s minus t. Well, this one went away when I factor the 2. Okay, so yeah, this one went away. And I have cosine of s cosine of t, sine of s sinus t. And that's what I have there. So that's actually my proof. And that was pretty cool. Now I feel smart. Yay! 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 Hi, I'm Prince. I'm smart. Yay!